Hello everyone. In this video, I am going to address few more important concepts, topics and questions. I will also answer those questions. They may be 1-mark questions, few numericals or concept based questions including 2 marks, 3 marks and 4 marks. Now let's start with glass. Glass, it is a hard transparent substance and it is used to make things such as windows and bottles. There are two types of glass. One is soft glass, the other one is hard glass. Soft glass, it is made up of mixture of 50% silica, 15% sodium carbonate, 10% calcium carbonate and 25% glass pieces. Whereas hard glass, it is made by heating silica with potassium carbonate and calcium carbonate at 1500 degrees centigrade. This hard glass, it is used in making hard glass laboratory apparatus like test tubes, beakers, tube lights, etc. Whereas soft glass, it is used in making window pans, light bulbs and other objects. It has lot of uses, right? For example, this glass, it absorbs, refracts or transmits light. It can be made transparent, that is see-through. You can see the other things through the glass. Then it can be made translucent, means you can't see the things through the glass, but then it will allow light to pass through it. That's called translucent. And then this glass can take excellent polish. Then it is an excellent electrical insulator. It is strong and brittle. Then it can be blown, drawn or pressed. That's the reason why the glass is molded into so many shapes, right? Our drinking glasses, jugs, mugs, decoratory items, so many things are made from glass. Because it can be blown, drawn or pressed. All these things can be happened at high temperature. Now similar item like glass, but it is not glass. It is known as ceramics. This ceramic is usually made of clay, aluminium oxide, silicon carbide and tungsten carbide. This clay or this white clay which is used to make ceramics is known as kaolin. Okay, that kaolin includes a kaolinite or hydrated aluminosilicate. This is the formula for that hydrated aluminosilicate. Al2O3SiO2 2 times H2O. Now before burning, this ceramics can be glazed. Glazed means it can be burnt many times. That means you can put it on fire many times. This when you put it on second or third time, that process is known as glazing. So before burning, these ceramics can be glazed to provide a smooth and colored surface. Okay, this will minimize the porosity also. Porosity means if you put water in it, will not come out. Okay. Then ionic and covalent connections are there between these atoms in many ceramics. Okay. Now the final product can be crystalline or semi-crystalline in nature. The final product means the product after glazing and burning and all that. When the product is ready, then it will be crystalline or semi-crystalline in nature. There are 4 types of ceramics. First are whitewares. For example, which we use, the cups, saucers we use in our kitchen, right? So they are the whitewares. Okay, cookware, pottery, wall tiles, they are all examples of this whitewares. Next comes the structural ceramics. Structural ceramics means bricks or the tiles on the roof or our floor tiles. They are all structural ceramics. Next comes technical ceramics. They are advanced or engineered ceramics. They are used in bearings, specific tiles, for example, in spaceship thermal shielding, biomedical implants, as ceramic brakes, or in as the nuclear fuels, or also in the ceramic engines. Okay. The 4th type of ceramics are the refractories. Refractories means these are the materials that are very much resistant to high temperature. They are used to create these crucibles. Crucibles means in Hindi they called it okhli, right? Okhli they called. You use it to grind this elaichi and all, no? That can be made through these refractories. That also are made of ceramics. Actually, we use that in labs, in research laboratories, we use them. Okay. Also, these refractories, they are used as a glass furnace. Okay. They are having this glass furnace applications also because they can withstand high temperature, right? That's the reason they are used as refractories. Now, glass is different from ceramics. How? This glass, it is a phrase used to describe amorphous materials. Similar composition is there, but it is not as hard as ceramic. The glass is not as hard as ceramic. It is amorphous material, you can say. See, glass means that kaanch ka glass in which you drink water, no, that is glass. Ceramic means the cup in which you drink tea, that is ceramic. Okay. Now, how ceramics are made? First, what they do is that white wet clay, it is shaped easily. Why? Because the ceramics, they have plastic property, right? Then again, once you give the shape, that shape will remain after it dries up. It will not change. And when heated to above 1500 degrees centigrade, one series of chemical reactions will produce other chemicals. Then glass and these chemicals, they will pack the tiny mineral crystals together. Then again, this object is glazed and again it is heated. The reactions in the glaze, no, they will cause the surface to be waterproof. That's what we told, that the porosity is reduced here. Now, these ceramics have few properties. First of all, they are very hard and strong. They are also brittle like glass. Then they are chemically inert and they do not corrode. This is one of the very important property of ceramics. Like this iron gets rusted, right? Like that, nothing is going to happen in ceramics. Because of this, what happens, no? If you find any ceramic item from the olden days, like for example in the Harappan city or in Mohenjo-daro, this archaeology people, no, they keep on digging the land and they are finding older time things, no. In that, if ceramic is there, then you will find it as it is. It will be as fresh as it would have been at that time because it does not corrode, right? Okay. Then these ceramics, they are good insulators of electricity and heat. Remember glass? It was also good insulator of electricity and heat, right? And they have high melting point and they are heat resistant like glasses only. And they are porous. But when you glaze them, you can reduce that porousness. That is, you can make them impervious. Now, there are three important differences between glass and ceramic. First one is that glass can be heated until molten repeatedly. But ceramic, you can't do that. Okay, it will get spoiled. Then glass, it is usually transparent, but ceramic, it is not transparent. It is not translucent also. Then glass, it has lower melting point than ceramic. So you need more heat to make ceramic materials when compared to the glass materials. Now there are two improved versions of glass and ceramic. Let's talk about the improved version of glass. They are glass optical fibers, smart glasses, photochromic glass and conducting glass. Now this glass optical fibers are important, so I'll talk on them only. A glass optical fiber, it is a pure glass thread. It will look like a wire, okay? And it can transmit messages modulated into light waves. It will consist of bundle of glass or plastic threads. And it is used in telephone companies, control board displays and in televisions, then in local area networks and also in medical instruments. What are the advantages of these glass optical fibers? Why do we use them? Because in these fibers, no, messages can be transmitted digitally rather than analogically. Now these days everything has become digital, right? Next, data can be transmitted over long distances without distortion and loss of signal. So the data, it will not get lost and it will not be disturbed also. It will not be manipulated also when you use these glass optical fibers. And then these are much thinner and lighter when you compare to the traditional cables. Now let's talk about improved ceramics. They are bioceramics, glass ceramics, ceramic superconductors and ceramic composites. In this, ceramic superconductors are important for us. So let's talk only on that. Now superconductors, they are materials that can conduct electricity with zero resistance. Remember, thus they will prevent loss of energy in the form of heat. That's why ceramic superconductors, they are used to make very powerful and light magnets, which are more powerful and lighter than normal magnets. So we are talking about materials we use in our daily life. Now what is paper? It is dried compressed mat of plant fibers. Basically, there are two essential stages to prepare paper. First is getting the pulp ready and then forming it and then again drying it into finished sheets or rolls. I want to explain more about paper in the form of questions, basically 1 mark questions. Now this separation of all the fibers from one another and their dispersion in water is called slushing. Okay, slushing. Then some fillers are used in the process of making paper. Those fillers are titanium dioxide, kaolin clay and calcium carbonate. Here in this question they are asking us which is not a filler used in the paper. So sodium hydroxide is not used. Other three things are used as a fillers in making paper. Then there is an interface between the pulp mill and the paper making process. That interface is known as stock preparation. And then the stock, which is a fibrous material, is prepared by a process known as beating and refining. So any one of them can be asked as a 1-mark question. Now let's talk about cement. Cement, it is a binder. It is a substance used for construction. Okay, we know that, right? It sets, hardens and adheres to other materials to bind them together. It is used on its own, but rather we put sand in it to build our houses and construction work, right? And sometimes they also use this gravel also. How they use? They use in some proportions. They know in which proportion if they use, then the building is strong. We here and now, we hear that building is collapsed or the bridge is broken. All that is happening if they are not putting the right amount of sand and gravel in the cement. If they are putting more amount of sand and gravel in the cement, then cement will lose its property, right? That's why those buildings get collapsed. Then how is it prepared? It is prepared by heating calcium carbonate, CaCO3, and a special kind of clay, which is Al2O3 SiO2 at a temperature 1600 degrees centigrade. You have to remember these formulae. Next, what are the uses of cement? We know that they are used for plastering, then masonry work, then pointing, etc. Then they are also used for making joints for drains and pipes. Then for water tightness of the structure. Then in concrete for layering the floors, then roofs, then constructing the lintels, beams, pillars, stairs, etc. In all the construction work, we use the cement. Then it is used where a hard surface is required for the protection of exposed surfaces of structures against the destructive agents of the weather and certain organic and inorganic chemicals. So these are the uses of cement. Now let's talk about fertilizers. What is a fertilizer? It is a natural or synthetic chemical based substance, and it is usually used to enhance the growth of the plant and to enhance the fertility of the plant. They offer three major macronutrients to the plants. They are potassium, phosphorus and nitrogen. And these fertilizers, they also nourish the microorganisms, which in turn help to maintain the fertility of the soil. There are two types of fertilizers. One is organic fertilizer, the other one is chemical fertilizer. Organic fertilizer, it is a substance which is obtained from the decay of animals and plants or the waste products of animals. They provide necessary nutrients to plants. Further, organic fertilizers are classified into two types. One is green manure, the second one is the compost manure. Then these chemical fertilizers, they are prepared artificially using inorganic compounds, and they are used in order to overcome the deficiencies of the plant nutrients. They can further be divided into three types. One is nitrogen fertilizer, second is phosphorus fertilizer, third is the potassium fertilizer. So either they may ask this entire thing for 3 marks or they may ask any one line from this for 1 mark. Now these fertilizers are very much important for us, especially in India, because we all have many farmers, right? Agriculture, it is the main occupation of a country. So we need to know what are the uses of fertilizers. You never know, they may ask this type of questions. Actually, see, one important tip I want to give you here is that while setting the question paper setter, he focuses on all parts. He wants to test your knowledge from all sides. Okay. So uses of fertilizers. They are used to provide additional nutrients to plants. Then they are added to improve the yield of the crops. Nitrogen rich fertilizers, they are used for greening of lawns. Then organic fertilizers, they improve the texture and fertility of the soil. Then gardeners use fertilizers to address certain needs of the plants such as nutritional needs. Then fertilizers we add to potted plants also, right? To replace the lost nutrients in those plants. Now let's talk about thermoplastics and thermosetting plastics. Actually, a 2-mark question was asked in your previous year question paper. So I have picked this question from your previous year question paper. Now, thermosetting and thermoplastics, they are two different types of polymers. They are mostly separated based on their molecular bond and how they react to heat. Okay. Thermosetting plastics, they are made from long chains of molecules that are cross-linked to each other. They have very rigid structure. Now when we talk about the difference between them, thermoplastic and thermosetting plastic. Thermoplastic, it can be synthesized by process of polymerization, basically additional polymerization. Whereas thermosetting plastic, they are synthesized by condensation polymerization. Then thermoplastics, they are processed by injecting molding, extrusion process, all types of molding, blow molding, thermoforming process, rotational molding and all that. But thermosetting process, no, it is processed by only compression molding and reaction injection molding. So I don't want you all to learn all this. If you know 2-3 points, that is more than enough. I am putting 5 points here. If you know 2 or 3 easy points, if you remember, that is more than enough for you in your exam. Okay. Then thermoplastics, they have secondary bonds between the molecular chains. Whereas thermosetting plastics, they have primary bonds between molecular chains and they are held together by strong cross links. Then thermoplastics, they have low melting points and low tensile strength. Means low tensile strength means they can easily, you can destroy them. Then thermosetting plastics, they have high melting points and tensile strength. Then thermoplastic, it is lower in molecular weight compared to thermosetting plastic. Okay. Thermosetting plastic is heavier when you compare to thermoplastic. Now, best example for thermoplastic is the polythene, okay, or the polyvinyl chloride, PVC. And this thermosetting plastic, you can say that they are used to make floor tiles, kitchenware and fire resistant fabrics, okay. So, this was all about the materials which we use in our daily life. They are all belonging to the same chapter, chemicals in our daily life. So, these were the topics which I did not address in that lecture of chemicals in our daily life. Now let's talk on the chapter periodic table. In this chapter, Mendeleev is the hero because he gave the periodic table. I am going to explain this chapter in the form of question and answers only because now we don't have time, right? I don't want to give tension to you all. I don't want to put you all in trouble by explaining the entire chapter. At least by watching my video, I want you all to grasp a few important points. You never know. If that type of question comes in the exam day after tomorrow, then you should be able to write those answers at least by attending my class. If you know at least few points, then you can make them in sentences and write in the descriptive answers. Okay. So what is Mendeleev's periodic law? He stated that physical and chemical properties of all the elements, they are function of their atomic masses. Function of their atomic masses means function of their atomic masses of those elements. Then for example, they can ask a question like this. Which group of elements was missing from Mendeleev's original periodic table? In the original periodic table, he left out some anomalous pairs of elements like argon, cobalt, tellurium. Okay, this all he did not include in the periodic table. Now what is modern periodic table? What does that law state? It states that physical and chemical properties of elements are a periodic function of their atomic numbers. Remember, atomic numbers. Now, according to modern periodic table, how many periods and groups are there? There are 18 groups and there are 7 periods. Periods means if you go horizontally, that's periods. If you go vertically, that is groups. Now, what is the difference between the Mendeleev periodic law and modern periodic law? In Mendeleev time, he was talking about atomic masses. Modern periodic table talks about atomic number. But then what is the difference between atomic mass and atomic number? Atomic mass will give you the total mass of the constituents that is inside the atoms, that is electron, proton, neutron and all that. But what is atomic number? It will give you the number of electrons present in that element, in that atom, number of protons present in that atom. So this type of a question can be asked. The atomic number of an element is more important to the chemist than its relative atomic mass. Why? Atomic number represents number of electron in an element. Most of the chemical property of an element, it depends on electrons in their outermost shell. This is called as valence shell. Remember the valence electrons. Hence, atomic number is more important to a chemist than its relative atomic mass. That's why we use modern periodic table nowadays. Now, this question I have taken from your previous year question paper. Eka aluminium, as predicted by Mendeleev, it is later called as Eka aluminium. It was the name given by Mendeleev to the undiscovered element which now exists by the name gallium. Okay, gallium. Not only for gallium, he had given names for scandium and germanium also. For this, I have put a question here. This type of a question can be asked. State the merits of Mendeleev's classification of elements. It generalized the study of elements. He put the elements in the periodic table just generally, roughly. Okay. He left some gaps in his periodic table of elements for the elements that were not discovered at that time. He just predicted and he put those gaps. Though they were unknown, he was able to predict their properties more or less accurately at that time. Okay. So much intelligent this Mendeleev was. Now, for example, what he did was he named Eka boron, Eka aluminium and Eka silicon to some elements as they were just below boron, aluminium and silicon in the respective subgroups. He don't know that they exist, but he put gaps and he put their names. Later, Eka boron was named as scandium, Eka aluminium was named as gallium and Eka silicon was named as germanium. So, this is the story of these elements. Now, this type of question may be asked. I have put it in the form of match the followings, but you never know. They may ask you as 1 mark question, 2 mark question or 3 marks question also. I don't know. But it's better. See, I am putting these questions in the form of fill-ups, choose the correct or descriptive manner or match the following. This is the method I am using to share the knowledge, to give you important points. Okay. In exam, they won't ask you exactly, but the points they will ask in a twisted way in their manner only. Okay. But if you know everything, you can put it in any way, right? If they ask you as 1 mark, you tick the right answer. If they ask you as descriptive answer, then you explain and come, isn't it? You write them in points. For that, you should have knowledge, right? Okay. So, this type of a question may be asked. In column A, they have given few things and in column B are to match. This is based on the periodic table. First is elements short by 1 electron in octet. Which are those elements in column B that you have to say? See, elements short by 1 electron in octet are halogens. Chlorine, bromine, all those are halogens. Next, highly reactive metals are alkali. Alkali metals, they are highly reactive. Then transition elements, they are non-reactive elements. Then actinides, they are elements of groups 3 to 12. Here you can see in the periodic table what are actinides, what are halogens, what are alkali metals. Just to go to a periodic table picture and then you have to learn all this. Okay. Then halogens, they are radioactive elements also. And then alkaline earth metals, they are the elements with the 2 electrons in the outermost orbit. So these are the type of points which you have to learn from this chapter periodic table. Okay. Now a few more questions. An atom of an element has the electronic configuration 282. It belongs to which group you have to say? Element with electronic configuration 282, it will belong to third period and second group. The valence electrons will give the idea of group members. As the electron will divide into 3 different shell, therefore the period will be 3. Okay. Or they may ask a question like this. Find the sum of period number and group number for phosphorus. For phosphorus, the group number is 15. The period number is 3. They are asking the sum, right? So, you add 3 and 15. The sum will be 18. Or this type of question may be asked as a 2 mark question. The element M has an atomic number 11. What is its electronic configuration? Which group does M belong to? Is M a metal or a non-metal? Write the formula of its chloride. So, the answer will be like this. See, the atomic number of M is 11, they have told. Then you can write the electronic configuration 281. Now, since the valence shell contains only 1 electron, it will belong to group 1. Then M is a metal because of this. Then its formula will be MCl. Whatever M is, if you want to make its chloride, it will become MCl. Okay. Now, there is one more question asked for 2 marks in a previous year question paper. They may ask this type of a question also. Elements X and Y belong to the group 16 and 2 respectively. Both belong to same period. Write the formula of the compound formed by X and Y. What is the chemical nature of this compound? See, one by one you have to address. Electronic configuration, first you write for X and Y. 12 and 16 means it will be 282 and 286. Then these both elements are present in third period. Why? Because there are 3 electron shells. Okay. Then these are likely to form an ionic bond as a result of transference of 2 electrons from element X to the element Y. Then the compound formed will be XY. So you have to write answers like this. Then you should know the chemical equations, how to write the chemical equations, how to balance them. For example, this is a question from your previous year question paper. Write the balanced chemical equation for the following reactions. Burning of magnesium in air. First you write this chemical reaction, then you balance. Okay, Mg plus O2 will give rise to MgO. You balance because there are 2 atoms of oxygen. You put 2 in the right hand side. Then again 2 Mg will become, so you put 2 in the left hand side of the Mg. Now this free magnesium metal, it is found to burn with a characteristic brilliant white light. You should know all this. Actually, this is the basic necessity of knowing the chemical equations in chemistry. Okay, these are simple chemical equations which you have studied in your school. Then this white flame, it will include strong ultraviolet wavelengths. Then the appearance of the white light flame is because of the formation of magnesium oxide when magnesium burns in oxygen of air. Okay. Now next is complete combustion of methane. You should write a chemical reaction like this. Methane plus oxygen will give rise to carbon dioxide and water. Then again you have to balance the chemical equation. Okay. Next, this type of a question also may be asked. At STP means standard temperature pressure. At STP, the volume of 6.023 into 10 raised to 23, the hydrogen atoms is. Actually, this is a trick. You don't need to calculate anything here. Actually, there is a hypothesis known as Avogadro's hypothesis. It states that 1 mole of all gases at STP occupy a volume of 22.4 liters and they have 6.023 into 10 raised to 23 particles. That's why 22.4 liters is nothing but volume of 1 mole of any gas. So either you have 1 mole or you have 6.023 into 10 raised to 23 particles. The volume will be 22.4 liters only. Next question. What is mass defect? Calculate the energy released when 2 AMU of mass is converted into energy. Actually, I am confused. They have not given this in your syllabus, nor in physics nor in chemistry. But this is there in your previous year question paper. So, I have picked a few important questions which may be asked this year also. But I am really not sure whether they will ask this or no. This is a little bit confusing. But still I cannot stop without addressing it, right? In case they ask what you will do. So I am taking the important points which are very easy. It will be easy for you all to grasp. Only so many things I am taking. So mass defect means actually in one atomic nucleus, no, actual mass of that atomic nucleus, it is always less than mass of proton and neutron. Total mass of proton and neutron, okay, which are present in the nucleus. When nucleus is formed, one energy is released. This energy, it is removed in the form of reduction in total mass. Now there is some missing mass, right? Actual mass of nucleus is something, but when you add protons or neutrons, that mass is something. You can take the difference and you can find that there is some more mass. But then what is that mass? We don't know. So we gave the name as mass defect for such missing mass, okay? But then it will account for energy released, okay? That you have to remember. Now, there is a formula for mass defect. What is that? Z is the number of protons into mass of proton plus N is number of neutrons into mass of neutrons minus Ma, mass of the nucleus. Means what you are doing, you are subtracting the total amount of mass of proton and neutron from the actual mass of nucleus. Then that answer will be your missing mass. That is your mass defect. Okay. So much if you remember, it's enough. Now here they have asked to find the energy released, right? Here actually Einstein's relativity theory is there. E is equal to mc square. You all must be knowing actually. You can use this formula here. Here this E is equal to mc square. In that m is there, no? That will be 2 into this 1.6 into 10 raised to minus 27 kg. Because he is talking about AMU, right? So he is talking about the 2 AMU of mass. So 2 into that. Into C is the velocity of the light in vacuum, which is 3 into 10 raised to 8 meters per second. Now this you have to do whole square because E is equal to mc square, right? So you put all the values and you multiply. You will get one answer. You will get around 3 into 10 raised to minus 10 joules of energy that is released when 2 AMU of mass is converted into energy. Okay. Now in your previous year question paper, they are asking questions from thermodynamics also, but it is not given in your portion. So what I have done is I have picked very few things, very basic important things that I am going to explain you here. Just take it lightly. You don't need to learn all those like it is not a hard and fast rule. Just take it lightly. Just you have a look. You just watch it. Maybe if they ask, it will be helpful. Okay. Now there are 4 types of gas laws. When we talk about gases, there are 4 types of gas laws. First is Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. See, they all deal with pressure, volume, and temperature of a gas. Okay. These all 4 people, they gave laws based on the gases depending on their pressure, volume, and temperature. Okay. Now, first is Boyle's law. It says that for a gas, pressure and volume, if you multiply, always you will have one constant. Or you can also say that pressure is inversely proportional to volume. The rest of things, mass and temperature will be constant. Charles' law says that volume is directly proportional to temperature. Gay-Lussac's law says that the pressure is directly proportional to temperature. Avogadro's law will say that the volume of gas will be directly proportional to the amount of the gas present there. Okay. Now putting all these laws, there is a gas law known as ideal gas law. This is equal to, now this gas law is PV is equal to nRT, where P is the pressure of the gas, V is the volume of the gas, N is the number of moles of the gas, R is the universal gas constant. Don't worry about it right now. T is the temperature. Okay. Now based on this, they have asked questions in your previous year question paper. That's why I had to mention those also. You never know. They have asked in 2017 also. They have asked in 2019 also. We cannot take chance, right? That's why I'm addressing these questions. And they are very easy. That's why if they were tough to understand or if they had some huge concept, it would have taken time. Then I would have not mentioned these. Okay. They are very simple. They are very easy. That's why I'm mentioning it here. Now the question is, a fixed mass of a gas at 293 Kelvin and 100 kilopascal pressure has a volume of 450 centimeter cube. At what pressure the volume of the gas becomes 2000 centimeter cube at the same temperature? So what you do, you take this Boyle's law, pressure is inversely proportional to volume, right? Now you take, for first scenario, you take as P1 V1. For second scenario, you take as P2 V2. Then you treat them as equal. P1 V1 is equal to P2 V2. You have P1, you have V1 and you have V2. With that you will get P2, pressure. That's it. It is very simple. Okay. You just take a paper and you solve this. You will feel very good. These are very simple things. It's good, no? You are getting 2 marks or 3 marks with these answers. It's nice, no? That's why I'm addressing these questions also. Now one more question. This is also a question from your previous year question paper. In the decomposition of H2O2, if the volume of gas, the oxygen gas collected at 40 degrees centigrade at a pressure of 1 into 10 raised to 5 Pascal was 100 centimeter cube, what would be the volume of gas at a temperature of 10 degrees centigrade and the pressure of 2 into 10 raised to 5 Pascal? See here, first you write the equation. Then you put P1, V1, T1 for all the values. Okay. Now you know the ideal gas equation, right? PV is equal to nRT. Now treat them as equal. When you treat them as equal, you take their ratios. P1, V1 by P2, V2 will be equal to T1 by T2. Forget about NR because it is not going to change, right? Number of moles will not change and the universal gas constant R, it will also not change. So you take the ratio. Then you have P1, V1, T1, you have P2, T2. Now you find V2 by putting all the values. That's it. Okay. They have asked a thermodynamic question also in your previous year question paper in chemistry. Explain isothermal process with an example. Actually, I don't know whether it is chemistry or physics because it's not mentioned anywhere in the physics. Thermodynamics, it belongs to physics and chemistry both. That's why I don't want to take chance. Okay. Anyway, thermodynamics means it is the study of relations between heat, work, temperature and energy. That's all. You remember so much. Okay. There are 4 important thermodynamic processes. One is isobaric, second is isochoric, third is isothermal, fourth is adiabatic. Iso means same. Okay. Wherever iso comes, it means that it is same. Baric means pressure. They are talking about pressure. So isobaric means this is a process during which the pressure of the system remains constant. In isochoric process, it is a process during which volume of the system remains constant. Okay. Heating of a gas in a closed cylinder. This is an example for a isochoric process. If you close the cylinder and you heat the gas, then the volume, it will remain constant. If the volume, it will increase more and more and more, then the cylinder will blast so much only. But more than that, nothing can happen. How much is the cylinder space? So much only that volume can be occupied. Next is isothermal, means same temperature. There is no change in temperature in isothermal process. That means that the temperature remains constant. Then adiabatic, the process during which the heat remains constant. The heat content of the system remains constant. This is known as adiabatic process. During this process, what happens? Heat is remaining constant means heat neither enters the system nor it leaves the system. Actually, this you can say that thermos flask is a good example for adiabatic process. But then temperature and heat, they are interrelated, right? So we cannot distinguish much. For isothermal process, you can give one more example, like if you are taking water out from the thermos flask, then somehow you are maintaining the temperature of that water. Then that is a isothermal process, you can say. See, this is the graph. There is a pressure volume graph. This is a famous graph. Whenever you talk about thermodynamics, you talk about the pressure volume graph. Okay. Here, if I plot the graph for isobaric, isothermal and adiabatic and isochoric, you can see that for isobaric, pressure remains same. For isochoric, volume remains same. That's why there are straight lines. But isothermal and adiabatic, they are not related to pressure and volume, right? They're related to temperature. That's why there are changes in those graphs. Okay, just keep this graph in mind. Now let's talk about carbon. In my before lecture, also in one of my previous lectures, I have asked you this question as an assignment. Now I am giving the answer. What is allotropy? Name two elements that exhibit allotropy. Allotropy, it is the existence of two or more different physical forms, but they are made of same chemical element, but their forms are different. Allotropes means those elements which exhibit this allotropy, they are known as allotropes. For example, carbon, it has two allotropes. One is diamond, the other one is graphite. Okay. Third is also there, fullerene. They are all different types of allotropes of carbon. Now there are three important properties of carbon. One is catenation, second is tetravalency, third is isomerism. Catenation means carbon, it has unique ability to form bonds with other atoms of carbon. Okay, this will give rise to large molecules. This property is called catenation. Remember, the unique ability of the carbon to form bonds with other atoms of carbon is known as catenation. Next, tetravalency. Carbon has 4 valency, right? So it is capable of bonding with 4 other atoms of carbon only, or it may also have bond with other atoms. No problem. It may be carbon or it may of other atoms, but then it is having capability of having bonding with 4 atoms. This is known as tetravalency. Isomerism. The compounds with iso means same, right? Remember, the compounds with identical molecular formula, but their structural formula is different. Such type of compounds are known as isomers. Okay. And those compounds which exhibit this isomerism are known as isomers. Okay. For example, isomers of butane. The formula is C4H10, but their structural formula is different. Here you can see. Okay. So these are known as isomers. Now one more important topic is there. See, I am talking about carbon, but I am not addressing all the topics. I have picked only very few basic, easy to understand and important topics. Okay. Hydrocarbons. They are organic compounds composed of elements of carbon and hydrogen only. Only hydrogen and carbon will be there. Their molecular formula will be CXHY. There are many different types of hydrocarbons like saturated hydrocarbons, unsaturated hydrocarbons, cycloalkanes, aromatic and aliphatic hydrocarbons, and many examples are also there. Methane, ethane, ethene, ethyne, etc. Okay. But why are they important? Because they are having very good applications. Like they are widely used as fuels. Like LPG, which we use for cooking, that they are hydrocarbons. Then CNG, they are also hydrocarbons. Then they serve as lubricating oil and grease. Then they are used as starting material in manufacturing of drugs and dyes. And they are also used in manufacturing of polymers. Remember, this can be a 3-mark question. Now, there are many types of hydrocarbons, right? In that, aromatic and aliphatic compounds are very important. They may ask you to mention the differences between the aromatic and aliphatic compounds. That's why I am putting this table here. Now, you have to address 4 things. First, what about the structure of the compounds? Then what is their flame test? Okay. Then what is the smell of those compounds, that is odor, and then examples. Okay. First of all, structure. Aromatic compounds. They are the linking of carbon compounds and they take place in ring structure. You can see the benzene ring here. It is an aromatic compound. Whereas aliphatic compounds, they take place in straight line manner. Here the methane, it is an aliphatic compound. And then while you do the flame test, that is when you put it on heat, then there is a sooty flame when these aromatic compounds burn. Remember, if you are PCMB from Karnataka, in your 12th standard and 11th standard, you must have done these laboratory tests in your lab. I am sure. I have done actually. I remember the sooty flame which is produced by the aromatic benzene. Next, the sooty flame is not produced when aliphatic compounds are burnt. Okay, aromatic compounds, they have pleasant odor. That's their name, right? Aroma. Aroma means good smell. They are the pleasant odor. Aliphatic, they are very unpleasant odor will be there. In lab, all will be some dirty smell you can have in the lab. That is because of these only, the aliphatic compounds. Then example for aromatic compounds, benzene and naphthalene. And for aliphatic compounds, it is butane and propane. Okay. Okay friends, I hope that I have not gone very fast. But if I have gone fast also, please don't mind. You pause the video, come back and again watch the video if you are not understanding. Because see, I am also majboor, right? Actually, there is no time. And there were few questions which I really wanted to address. I don't want you all to miss these questions. Okay, because this is very simple and easy things. Just if you watch the video, you can just keep it in your mind. You can write in the exam if they ask. Okay, that's the main reason I have made this video. I made it in little bit hurry, so don't mind if I have made any mistakes. But still you let me know in the comment section, because if I make any mistake, I will ping it, so that you all will not have wrong information, right? So that is one thing. One more thing is, please do like, share and subscribe to my channel. And don't forget my channel after your exams. Please forward my videos and tell about my channel to your juniors. Okay, maybe they will also be needing help for their future exams, right? So help them also. Please share my channel. Then what else? I will try to make one more video. I will try to talk about how you have to attend your exam. Okay, I will try to do it by tomorrow. Nothing else. That's it. Okay, all the best. You have only less time now, 1 or 2 days. So forget everything. Just remember that you want to become a teacher, a government teacher, and give children your knowledge. Okay. For that, you have to read now. You have to practice now. You have to work hard now. Okay. Don't waste even 1 second. Only your exam, only your topics, your physics, math, chemistry, your GK, English, only that should be there in your mind now. Nothing else. Okay, friends. All the best. Take care. Bye.